So for today's warm-up, we want to find the component form of vector v and sketch the specified vector operations geometrically given vector u and vector w. So first thing we're going to do is I am going to plug in u and w into those two spots. So I have scalar multiplication of 0.5, which remember will do half the magnitude, 3 times vector u, so this is going to triple the magnitude of vector u, plus vector w. So I'm going to leave the 0.5 there. This is going to become 6i minus 3j. So combining like terms, 6i plus i is 7i. Negative 3j plus 2j is minus j. Now we can distribute the 0.5 inside, so we'd get 3.5i minus 0.5j. So let's see, find the component form. So our component form, remember, is inside of the arrow type brackets, is going to be 3.5 comma negative 0.5. Now let's draw this geometrically. So first thing I'm going to do is, if I look at this as 3/2 u plus 1/2 w, this is just going to be easier to draw. So 3/2 u would be, if I take 3/2 times 2i, that would be 3i. And then 3/2 times negative 1 is negative 3/2 j. So if I graph that, that is going to go from 0, 0 to 3, negative 1.5. So it would be that directed line segment would be 3/2 u. And if I did the same thing, if I took 1/2 times the w, so 1/2 w would be 1/2 I plus j. So it would go here from 0, 0 to 1/2 1. So that's 1/2 w. So my directed line segment is going to be the addition of those two. So if I added those two together, remember I would take the initial point of w and move it to the terminal point of u. So I'd be going over 1/2 up 1. So that would be, whoops, sorry about that. Over 1/2 up 1 would move me up to 1/2. So that would be, this directed line segment here is the 3/2 u plus 1/2 w. And remember, I could have moved the 3/2 u up to the terminal point of 1/2 w, and I would have got the same thing. And we can double check that that verifies with this component vector, that I know I should go from 0, 0 to 3.5, negative 0.5, which it does. If vector u is a unit vector, so remember that means that it starts at 0, 0, such that theta is the angle measured counterclockwise in degrees or radians. It does not matter which one we measured in. For the most part, we are going to be using degrees here. From the positive x-axis to u. So that's just a fancy way of saying, hey, remember this is our positive x-axis here. This angle would be measured as like 150 degrees. That's all it's saying, is that we're measuring counterclockwise from our positive axis x. So we would have, since we know that it's a unit vector, the radius is 1, just like on our unit circle, we have that vector u is the component vector of xy. We know that every point on the unit circle, the x value is the cosine and the y value is the sine. So moving that from component form to our other form, we get the cosine of vector I plus the sine of vector j. So it follows that if vector v is ai plus b times vector j, well, if b is sine and a is cosine, well, tangent is sine over cosine, so the tangent of the angle would be equal to b over a. Remembering then that to solve for theta, we would do the inverse tangent of b divided by a. So it gives us a quick way to find our angle theta. So find the direction angle of each vector. We could draw this geometrically, and we could look at the point 3, 3. And that's what vector u would look like. Well, if I wanted to find the angle back to the positive x-axis, this side is the length of 3, this side is the length of 3, so the tangent of theta is equal to 3 over 3, which is 1. That would give us 45 degrees. And we could verify that with our calculator. The quicker way, of course, is to take b divided by a. So 3 divided by 3 is 1, and then we take the inverse tangent of that. So we could do it non-graphically. Let's do it non-graphically here for letter b. So I would say the tangent of theta is equal to negative 4 over 3. Sorry about my smartboard. So on our calculator, make sure we're set to degrees. So what we're going to do is we're going to do the inverse tangent of negative 4 divided by 3. And that gives us negative 53.13 degrees. So remembering negative 53 degrees would look like this. But we always want an angle that comes from the counterclockwise region. So to find that angle there, I would simply take 360 minus that answer. And that would give me, sorry about that, I wanted to take 360 minus the 53. And we get 306.8699. Find the component form of the vector that represents the velocity of an airplane descending at a speed of 100 miles per hour at an angle of 30 degrees below the horizontal. So we can see right away that 30 degrees below the horizontal gave us 210 degrees from the positive x-axis. And we want to find the component form of that vector. So the first thing you notice is that they labeled the vector with the magnitude of 100 because it's 100 miles per hour. So we look at our formula and we go, okay, vector v is equal to the magnitude of vector v times the cosine of theta plus the magnitude of vector v times the sine of theta. And we also have vector I in here and vector j here, that it separates out the x value and the y value. Well, I already know that the magnitude of vector v is 100, and the cosine of theta, that's going to be taking the cosine of 210 degrees. And then the vector v magnitude is 100 times the sine of 210 degrees. So, remembering if this is 210 degrees, that makes a 30, 60, 90 right triangle. So this is x, 2x, and x times the square root of 3. So we would take 100 times the cosine of this angle would be square root of 3 over 2. Plus 100 times the sine of 210 is going to be 1/2. The last thing that we can't forget, of course, all students take calculus, so here in quadrant 3, both the cosine and the sine are going to be negative. Multiplying here, we would get negative 50 square root of 3i, and here I would get negative 50j. So our component vector is negative 50 square root of 3, negative 50. So here for our last slide, we see that we have a boat at a boat ramp. A force of 600 pounds is required to pull the boat and trailer up a ramp inclined at 15 degrees from the horizontal. So we can see here at angle W, they labeled that as 15 degrees. Find the combined weight of the boat and the trailer. So what they did is they drew in a few extra vectors for us. They tell us that vector BA, so this vector here, is the force of gravity. In other words, that tells us the combined weight of the boat and the trailer. Vector BC is the force against the ramp. We know that that's where the force of the ramp is, or the boat is going. And then AC, this is what we're wanting to find, or that's what they give us, is the force required to move the boat up the ramp. So this is 600 pounds. So when I look at that, we know that since this angle is 15, these two triangles are similar. We can go back and review a little bit of geometry and prove why those triangles are similar. But we know that that angle then would be 15 degrees. So when I look in that triangle, I am trying to find the magnitude of vector BA. So I have a right triangle here. This is my hypotenuse. This is my opposite from the 15 degrees. And this is my adjacent. Since I have a right triangle, I know that I can use SOHCAHTOA. So the one that uses opposite on a hypotenuse is the sine. So we'd say the sine of 15 degrees is equal to 600 over x, where x represents the magnitude of vector BA. If x is on bottom, we swap them. So I'm going to take 600 divided by the sine of 15 degrees. So grab the calculator. (600) divided by the sine of 15 is 2,318.2, and our label in that is pounds. So we found that the weight of the boat and the trailer together is 2,318 pounds.